All right, so I'm going to go ahead and work the marble problem. That is on our suggested problems for probability on day one, which is number 4. The question reads that 2 marbles are drawn at random without replacement from a box containing 2 marbles, 2 blue marbles and 3 red marbles. That tells me there's a total of 5 marbles. And then part A says list the sample points. Sample points, if you remember, are possible outcomes. Well, the first thing I need to do is I need to set up some sort of definitions because I'm not going to keep writing red and blue. For each marble, I know I have a total of 5 marbles. I know that a blue marble, there's going to be one of them, so I'm going to call that B sub 1. And for another the other blue marble, I'm going to call it B sub 2. For the red ones, I'm going to do the same thing. I have 3 red marbles. I'm going to call that R sub 1, R sub 2, R sub 3. So I don't have to keep writing blue and red over and over and over again. On part A, it says list the sample points. So it means what are all the different combinations? Of course, order doesn't matter here. You can go red sub 1, blue sub 2. Order doesn't matter. So the first thing I'm going to do is I'm going to calculate, once I do everything, how many sample points should I have? Well, because order doesn't matter, we can actually check this with combinations. So we can actually do 5 choose 2, which becomes 5 factorial over 2 factorial times 5 minus 3 factorial. Now from here, you can put it in the calculator or calculate it by hand. I'm really indifferent to how you do it. This becomes 5 times 4 times 3 times 2 factorial over 2 factorial times 2 factorial. These cancel. This gives me 5 times 4 times 3 over 2 times 1. Of course, 2 goes into 4 2 times. This really leaves me 5 times 2 times 3. Oh, I'm an idiot. I copied the problem down wrong. One of y'all's biggest mistakes, I did as well. This should be 5 minus 2. This 2 factorial should be 3 factorial. And that means I only have to do 5 times 4 times 3 factorial because my 3 factorials will cancel. That really just gets rid of this 3 right here. And that leaves me just 5 times 2, which is just simply 10. So once I get everything done, I should have 10 different combinations of blue and red marbles. Really the best way to do this is just kind of get in and start. I like starting with, pick one marble, list the other 4 with it, pick another marble, list the next 3 with it. So there is no overlap here. All right, so here comes my outcomes. I want to have blue sub 1, blue sub 2, blue sub 1, red sub 1, blue sub 1, red sub 2, blue sub 1, red sub 3. So now that I've exhausted all the different possibilities, I'm going to go to blue sub 2. Blue sub 2, I don't need to do blue sub 1 because I already have it right here because the order doesn't matter. So I'm just going to jump down to the reds, red sub 1, blue sub 2, red sub 2, blue sub 2, red sub 3. Now that I'm done with all the red different combinations, I'm going to start with red sub 1. So red sub 1, I don't need to do red sub 1 and blue sub 1 because that is right here. And I don't need to do red sub 1, blue sub 2 because that is right here because the order doesn't matter. So now I do red sub 1, red sub 2, red sub 1, red sub 3, and then last but not least, red sub 2, red sub 3. And I have all the different combinations. And if I actually add these up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And up here it told us we should have 10 total combinations when we're done, and we have all of those. All right, so B says assign probabilities for each sample point. Well, pretty straightforward. If there's 10 of them, I have an equal chance, so I'm just going to take 10. And each one of these is going to be one of my options of the 10. So my probability is going to be 1/10 for each one of these. All right, so letter C on this problem, it's going to ask us to find probability of A. My event A is that I get two blue marbles. The probability of event B, well, event B is a red marble and a blue marble, and the probability of event C, and of course event C here, it says the two red marbles. So the way we're going to actually calculate this is we are going to find the probability of A. I'm going to write out and add up, because these are mutually exclusive events, all the different ways that I can get two blue marbles. Well, the only way I can do that is B sub 1, B sub 2, which is 1/10. So the probability of event A occurring is 1 out of every 10 times, or 0.1, or 10% of the time. However you want to look at it. All right, the chance of probability of event B happening. Well, I'm going to list out all the different possibilities of getting a red and a blue marble. Well, I can get blue sub 1, red sub 1. I'm going to have to add them up. I'm going to get blue sub 1, red sub 2, add them up. Blue sub 1, red sub 3. Blue sub 2, red sub 1. Blue sub 2, red sub 2. And then blue sub 2, red sub 3. Well, each one of these is 1/10. All right, so now there's 6 different ones here, so I have 1/10 6 times. When I add those up, that becomes 6/10, or 2/5, because they both have a 2 in common. It should be 3/5. Or you could say 0.6, or 60% of the time. All right, the probability of event C happening are going to be all your combinations added together, in which you're going to get two red marbles. Well, that's going to be red sub 1, red sub 2, plus red sub 1, red sub 3, plus red sub 2, red sub 3. This gives me 1/10 plus 1/10 plus 1/10, which gives me 3/10, which is 0.3, or 30% of the time. Really not that difficult of a problem. It just takes a little bit to kind of wrap your mind around.